Welcome to the next class. Today class actually we are going to see about control system. What is control system? Control system, the sense you can just look at the word. From the word there are two things. The first one we can talk about control. The next one is about system. So what does it mean? The combination of this control system is what? Control system. So control the sense if any part of the device is going to control a set of device that can be either it will given commands or it will give set of instructions or it's going to manage something or else it is going to regulate something. That is all we used to call it as an control. But system is what? System is nothing but interconnection of so many components. Interconnection of components together we can call it as an system. So combination of control system we used to call it as a control system. So a control system is a device or a set of device that manage, commands, directs or regulates the behavior of other device or a system. So we can tell the example is daily you people are moving around the road, you can able to see there is a traffic light control system, right? Not only that, even we all know about air cooler. Air cooler is an automatic temperature control system. Based on the temperature, the condition of the air cooler is operating. That is one example. The another example we can talk about is traffic light control. So traffic light control, which is nothing but according to the instructions or according to the predefined set of time it operates. The another one is about automatic flow and pressure control in the industry process. So these are some of the examples of control system. So a system which consists of number of components connected together to perform a specific function. So it's not only that, the combination of those doing something, some operations in which output is controlled by the input. That is what control system. A system which consists of a number of components connected together to perform a specific function in which the output controlled by the input. So generally control system there are two different types. One is open loop, the another one is closed loop system. So from the word we can say that open means that is you have an system. So in short I can use open loop control system. So OLS, I am just going to give an input and I am just going to get the output. This is what? Open loop system. So you don't have any feedback, right? But closed loop, what is the difference? Closed loop in the sense there will be an feedback. So input, this is called error detector. Then you have a controller. Then your open loop system, you have an output. Then this thing is going to be fed back to your error part. So this particular block we had a unit called feedback. So here positive, negative, this positive and negative will give you the output of your error detector. And here this combination may be positive feedback or there are two feedback, positive and negative feedback. Positive feedback in the sense in the error detector you will have both positive and positive. Negative feedback in the sense this will consist positive and negative. So generally in the design of the control system they used to go for negative feedback system because this is the system will give you the correct output. So that is why they have chosen negative feedback. And I would like to inform that if suppose you want to control a pressure in a particular tank at a desired level. So now my focus, we are just going to derive. I am just going to implement pressure control. In the pressure control system, there is a tank. I have to control the pressure. So what are the components I am in need of? I have to go a station, that is my tank. Then for sensing this particular pressure, I am in need of sensor. Then how I am going to control? For that I am in need of controller. So whatever the system you are going to implement it using control system, you were in need of. For example, the pressure control system, you were in need of a tank, then sensor, then controller, then for adjusting, because sometimes according to the controller and according to the sensor, if I want to control the pressure, then how I can do? I have to go for control valve, right? So control valve is another part. This control valve which is operating final control element. Okay, so you can just look at, I am in need of controller part, I am in need of sensor part, then I am in need of control valve, and then tank. So these are all the 4 things were very important to implement the pressure control system. So the same thing I am going to implement it in my closed loop system. So the closed loop system, you have a controller, then you have an open loop system. That is nothing but what is the process you are going. So according to this, here the process is your pressure. Then we have to give a feedback. That feedback is here final control element. Then error detector, that will calculate the deviation of your input and the feedback unit. So if this particular signal is 5, this signal is 3, I am just going to implement positive, negative feedback. What will be the output of my error detector? 5 minus 3, it's going to give 2. So that is what my error detector is used to function. So error detector, which will be give you the deviation of your actual minus your desired value. That is the purpose of desired error detector. Okay. And for another example, our human body is also function like a control system. How? Your brain. The brain will act like a controller. Your brain is act like a controller. Then is it we have sensor? Yes, of course we have a sensor. The sensors are like eye, ear, skin, then nose. These are all the sensors. Which one is final control element? Because if I want to do some operation, then I have to go for hand, leg. If hand and leg I am not going to perform anything, then this is not used, right? And which one is taking action? If I want to eat, if I want to sleep, who is telling and who is doing the thing? Your brain. Okay, so according to the need of the activation, so your brain function, right? So the human body is also another control system, is doing a perfect control system. So brain is act like a controller, sensor act like an eye, ear, skin, nose. Final control element is your hand and leg, and the error detector, which is nothing but your brain. Right? I think you have understand the basics of control system and the examples. So now we are going to see about the types. So open loop and closed loop system. What is open loop system? Your open loop system, which is nothing but a control system in which the control action, that is important, is independent of the output. How we can say independent of the output? Because I don't have any feedback unit. So it is independent of the output, then it is called open loop control system. So manual system, whatever the thing we are going to do as manual, it's all an example of your open loop, in which the process is totally independent. It is not depending on the output. Here the process of output is totally independent of the controller action. That is what open loop system. So here the open loop system example, you have a desired process response, controller, the process input. So that will be the input of your process and the process output. So this is what an example of your open loop control system. Example, right? What are the applications? So application, coffee maker, timer based cloth dryer, then stereo system and hand dryer. How? You can just look at the first one. It is a coffee maker. You all know coffee maker, right? But in coffee maker, according to the output, it is doing any corrective measures? No, it's not. Because if you want to make a coffee, already they have been programmed with some predefined limit. The programming thing, there is a time limit they are setting by the operator, right? According to that, you will receive the output. That is what your coffee maker. Then cloth dryer, here also time. It doesn't matter how much the cloths are dried. Whatever the time, fix it already. According to that, it will perform. Then stereo system, you have to do manually, right? If I want to get the voice of the music in a low sound or high sound or in a medium sound, it is all based on the operator, right? So the operator has to perform. The next one is advantages. So from the diagram itself we can understand it is simple construction, right? Then economical, easy to use, and it is stable. But you will not get an output accurate. Why? Because here you don't have any feedback. So what will happen? No corrective measures. So the disadvantages is inaccurate. Then any change in output cannot correct it automatically. That is what the disadvantages of open loop system. The next one is about your closed loop. So closed loop system, already I have been discussed in the previous first slide. Your closed loop control system, which consists of a controller, then you have a process, error detector, and the feedback. So here what will happen? Whatever the output you are going to get, it is depends on the input and the feedback. Your input as well as the feedback element depends on that your output is going to generate. So according to the need, it will adjust, right? Adjust itself based on the output generated. That is what closed loop. So this closed loop can be derived through your open loop along with your feedback. So the feedback automatically make a suitable change in output due to the external disturbance. So external disturbance, if there is an error, that will also get nullified through this. That is what performing in your closed loop system. So closed loop system, the diagram you can just look at. The control system, you have an input, and this particular block we used to call it as an error detector. So this error detector they used to have like this, okay? So positive and negative, and either you can use positive negative or you can use negative negative. So positive negative, which is negative system, positive system, sorry. So positive negative means it is negative feedback system, positive feedback system, but this system will give the output stable, that is your negative feedback. So this is error detector, and the error detector output is given to your controller. Then you have a process, output and the feedback. Okay, this is what closed loop system. So the application is automatic electric iron. Here the heating element, I am just going to control the heating element according to the temperature. So there is an action, controlling action is going to perform. Control action, that is what your closed loop system. Then another one is stabilizer. You all know servo voltage stabilizer, according to the voltage it automatically do the operation, right? That is the reason why all the people, even the fridge as well as your TV systems are connected with the stabilizer, right? So your stabilizer will do the controlling action. Then air conditioner, its function depends on temperature. So you can just look at the diagram. You have a controller, positioner feedback. I am just going to control according to the sun, the solar operation, that is what the diagram, and here it is sun seeker solar system. So based on the heating, that is your temperature range, this is going to operate. So based on that, the positioner output will given to controller, then your feedback, then this will forms like a closed loop control system. So what are the advantages? It is more accurate even in the presence of non-linearity, that is very very important. The next one is error can be reduced, then system is less affected by noise, then facilitating the automation. So that is what your advantage. Disadvantages of closed loop system, they are very costlier and they are complicated, then it needs some maintenance, then it also leads to oscillatory response. It reduced because the gain is reduced. What is the meaning of gain? So the gain, which is nothing but output divided by input, because here we have a feedback element, because of that the error detector will produce the deviation of your actual and the desired. So automatically the value is going to change, so it leads to gain, right? So the gain value is going to reduced due to the presence of your feedback. Then stability is a major and more care we have to taken into account, because the stability is very 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 important, right? So whenever you are going to design a system in the control system point of view, the main thing is the people used to taken care of stability, then gain, response time, then noise, then settling nature. These are very very important when you are concentrating on designing a system. Either you are going open or closed loop, whatever the system they are going, they have to taken care of these 4 parameter. In general control system, there are 4 things very important: flow control, temperature control, pressure control, then level control. These are the 4 things are very important in industry. So if the people doesn't have enough knowledge on control system, then they can't able to perform, right? Okay, so this is what today class discussion. What is control system, what are the different types, what is open loop and closed loop, how we are going to construct example, application, then advantage and disadvantages. So next class we can see about MIMO system. Okay, thank you so much.